Hi all. This is Manoj, and I'm the trainer for Uplatz. Today we are starting the session for Docker overview, and let's start the session with the Docker. Okay. So if you confirm if you're audible, I'll start the session right away without wasting any time. So see, Docker in the IT industry is booming like anything, and the reason for booming the Docker containerization topics is it's like before a Docker, let's say we are discussing the IT industry, and the earlier in the IT industry, the deployment for the image or the deployment for the software into the production or in the development IT industry, we used to do it like with the monolithic architecture. And in the monolithic architecture, what we used to do, if you see my screen, let me see that. Uh, See, the if you before coming to the Docker architecture, we used to use our system with the bare metal systems and virtualization. So in the bare metal systems, what will happen there is only one application has to take care all the task. It's like multiple tasks will take care by the one application, and that will consist of operating systems. It's like binary and library file will be more. So the challenges come where let's say you have uh, one code, and that is working in one environment, and when it has been deployed to your next environment, either it's a dev test or production. The problem will come like the same set of the code will not work on the other environment. So uh, so what happens let's say if you compare your uh, IT industry, current IT industry, let's say we have uh, database, we have a finance application, database application one, and one more application we have, and that what happens that we have let's say that all has three or four or multiple application has been installed on one single host. So earlier, what we used to do, one single host has to take care all the other tasks. Okay, and so the problem came here like it will be it will be like it will consume more memory, more hardware, and all. And when the Docker comes, it's like it's a containerization topic. It's a lightweight alternate of virtualization. So what happens that everything coming into an image. Okay, so what happens the image will contain it's like binary and library file on top of your OS operating systems, and then when it will deploy to your it will encapsulate it all your binary library file and a small amount of OS for it's for making one application. So that is called an image. So if you see here, so before Docker, the concept was like virtualization. Virtualization we earlier we used, and it helped us to create software based on virtual version of computer resource. These computer resources can include computing devices, storage, like anything. So now after this the containerization topics or the Docker overcome this virtualization, because containerization is a lightweight alternative of virtualization. So say let's say one operating system or one host is having some virtual machine. So what virtual machine will do? It will consume the resources and OS operating system from one host. So you can have a multiple VM on single host. But in case of containerization, what happens that containerization it will it's an image. It's like a binary and library file encapsulated with the OS systems. So it will make one image, and from that image you can create one container. You can say it's a container is everywhere. All your each and every task or application, you can say that's a container, because if you have a Docker image, you can run a container with the Docker image. So this involves encapsulation and application in a container, which is its own operating environment. Third, instead of installing the OS for each virtual machine, containers use the host operating systems. So if you compare your virtualization with your containerization, so it's like first term will come isolation. Isolation means like it will separate your the communication from one to another. So in the virtualization, what happens provides complete isolation from host operating systems and the other VM. So let's say you are having uh, one one physical machine, okay, and in the one physical machine you have installed multiple VMs on that. But in case of containerization, what happens? It typically provides a lightweight isolation from host, from the container. It doesn't provide a strong security of boundary as a VM. So it means that let's say I want to run 10 multiple application on one single host. So we can do that. It's like what we'll do, we'll divide, let's say it's one cart application, and it's like one paying application, one infra, or one billing it is happening. So let's say multiple application I want to deploy in one of the hosts. So what I'll do, I'll make a separate chunk. I'll use the microservices for each of the application, and deploy in the host machine. So what will happen? So it's like each microservices will have a binary file, one library file, and a small amount of operating systems which has to needed. It's like it will be an MB, and on top of this binary library or application will run. So that is called an image. So it's like same way here it's a containerization. Operating systems, if you talk, so in virtualization it runs complete operating system including kernel. But in containerization it will not run from the power on self systems. It will just take a small amount of MB. It's like a very light amount of operating system will take to boot the container. It will be very fast. It's like fraction of second your containerization or your container will boot. But in case of virtualization, it has to boot your kernel, your CPU memory, and then only your VM machine will come up. And if you talk about guest compatibility, so in case of virtualization, it runs just about any operating system inside the virtual machine. Let's say here in virtualization, there is one concept called hypervisor. So let's say you have a operating systems on top of your operating system. On hypervisor will be there, and the hypervisor is the things which will allocate the memory or resources to your VMs. But in case of containerization, it runs on the same operating system version of the host. It's like in one host machine, and you can deploy your multiple containers in one single operating systems in n numbers of you can say host. Each one container or each one container will be your single machine. You can get that. It is so fast. It's like a thousands or of container you can deploy in your host machine at a single sort of in a single sort of time. Deployment, what happens that deployment individual VMs using hypervisor software. So it's like it is on sitting on the top of your host machine, and which will provide the resources and memory to your virtual machine. But in containerization, what happens? It will deploy like multiple containers using an orchestration tool will be happens. So it will deploy that now 100 or multiple thousands container in a single operating systems. In case of virtualization, the storage capacity it will be like a virtual hard disk will be there, and for a single VM, like let's say server message block will be there. But in case of containerization, what happens? See in the if you talk about storage, there are two types of storage is there. It's like a storage and persistent storage. It's like local storage will be there on each container, but the best way or the standard way to use the keeping your volumes or mounts on the NFS or other sources, so that because the container, let's say, whenever it is down, your local storage will be gone. So it is best practice to mount this storage on any NFS or any cloud or any other operating systems. Load balancing, it's like virtual machine, and load balancing is done by running in one another servers in a failover cluster. It's like uh, let's say you have a cluster you configured for two or four virtual machine. So what happens that one if one goes down, the other will be running other servers in a failover cluster. It's like you have to failover to the other, but it's an in a containerization concept. What happens? An orchestration can automatically start and stop containers. And let's say if it is understanding like I need to scale up at a certain amount of time. If I need to increase the number of containers or instance in a like defined the load balancer, so it will increase up, scale up. As it can do, let's say the load is very less. So in that case, we can scale down the number of containers using. We can scale down. Now coming to the networking concept, it uses virtual network adapters, but in containerization, it uses isolated view for the virtual network adapters. Thus, it provides a less virtualization. So, by the way, in the Docker, there are so many like network concept we have. It's like overlay network. It's like host network, and then I means Ethernet network we have. We can use it's like I think five or six network concept we have in Docker. That I will discuss later. But it's like there are so many options in the container in the Docker we have given to use as a container topics. So now, as I said earlier, like before containerization, there was a like if you have one code that developed by the development, and the problem is that is not working in your dev or some let's say production machine. So the concept is like the compatibility or the code. Let's say you are running on the test environment, and in your environment it is working fine, but the same things, if you have deployed that into the other environment, it is saying like it is some compatibility issue or that is not working there. So that's what where the Docker came. Docker, what it does, it like it's a, you can consider it's a briefcase, and you are having all for running one application whatever needs. It's like library file or a binary file or a small amount of operating system. That is everything is there with a container image, Docker image. So whenever if you have a Docker image at any place, you just run that. It will your container will be ready. So that's what it's a earlier as I said earlier, we were using like monolithic architecture. So let's say I have a client browser, and I am having three. I want to run three applications. So let's say payment application, shopping cart, or inventory. So in the monolithic architecture, what exactly we will do? The single instance or single host, it will take care all these our all three tasks, or three, you can say three applications we deployed. So it's like the drawback is like the flow will be high, the load will be high, because it all single instance has to do all the three tasks. But in the micro services, we used to do, we are doing that. So let's say we have a three we need actually, let's say here in the client project, we need three application here. So in the microservices, what we did, we divided all three applications into single chunks. It's like payment application one, other things, shopping cart and inventory. So what happens here? The single host, it will take care it has to take care other things. There is nothing to do with the shopping cart here. It's like they can communicate with each and other application, but the microservices, the what happens, the load will be distributed to all everything separately. It's like for payment, let's say task, let's say we have here, it is having separate binary, separate library, separate operating systems and application running. Same things here. So it's a, with the Docker image, what we did, we separated all the shopping cart in the payment, the payment, shopping cart, and went with all three applications. So user can, if they want to access the payment application, then they can access this one. If they can't, they want to access the shopping cart application, they can access here. So what happens here? The load burden here. Let's say earlier, all single instance has to do, but here microservice architecture, I divided my same application into three parts, three small chunks. So in this way, our now the IT industry is working on that. So if you if you ask like what is exactly this microservices contains, so as I said, this the one application, it will have your like whatever need to run the application on in any operating systems. It's like binary file, library files, and operating systems here. So each and every the packages, it is tightly scoped. It's a strongly encapsulated, means like let's say if it is working here in one place, and if it is like I already given like same architecture we need here in anywhere, you just take this image in any other place, the same, your container will be run, definitely it will run. This will not fail because it is already encapsulated and working. It just need to run, it's a Docker image already. So in any place, just take that, just run that image, your container will be created. It's loosely coupled and independently deployable. It's like you can deploy anywhere. If you are having that image, you can deploy it. And independently scalable, it's like it's like you can communicate with your other uh, application, but the thing is, it's like separate. It's like communication will happen. Like let's say any other application can communicate with the other shopping cart application, or inventory can communicate here, but these are individual. This is separately work. Other separate library, binary, and operating system. All are three different operating application working here. So okay, now if you see here, like if let's say you have a Docker image ready, and you want to deploy your the same code here. So that's what a Docker team. Docker, as we know, like Docker, it's a tool. It's a tool for deploying your microservices architecture. So if you see here, like which builds a single application by breaking it into a collection of independent, loosely coupled services. By using Docker containers for building microservices, DevOps team can test code without fear of negatively impacting the rest of the application. So if you hear here, so if you see here, let's say we have one shopping cart application here. So it doesn't, not like it will not impact the other application or other payment card here or inventory. It is single entity. So, and if you have Docker image for payment application, so definitely you take that and your container will be ready, or you can launch your container in any of the compatible operating systems. So it's a, that's what Docker coming to picture. It's a tool. Uh, for deploying your container images, and then your container will be created. So if you talk what is exactly that Docker image contains. So if you said like what is container introduction? So containerization in DevOps is the process of packaging an application and its dependencies. That's what this is like a binary or library file into a single unit. So it's like one package. If you want, if you created one image for your application, like shopping application or anything, it will definitely run in any of the environment. You take that image, you keep anywhere, or you just keep any, like we have Docker and all, and you just pull that, push that, and you run that. So your container will be created, or container that can be run on any infrastructure. So it's like wherever you take that image and you run your container anywhere. So why container? Because now it's question will come like, what is Docker feature have? Now, why Docker? The IT industry are using Docker nowadays. Uh, so if you say Docker is a tool, but it's an open source platform, and the Docker is very lightweight and consistent weight of the delivery application. It's like easily we can install your Linux machine and Windows machine, because that will use a client only. and you can deploy your container anywhere. It is very fast. It's like it doesn't need the booting process uh, for your container is it's like see, because it is using it's a less amount of MB to boot the container, so it will be very fast to boot your applications. And on top of your booting process, your library binary and then application is existing. So it is very fast. It will take fraction of second to boot your container. So that's what in the big IT industry we are using Docker. So it's like thousands or in numbers of container you can run a fraction of seconds. Segregation of duties. It's like what happens. Like let's say you have 10 container, and you want to segregate. You want to assign a task to each and every container. So that's what we can do that. So let's say in a single group you assign for container, you assign the task also. So it can communicate. That will study on the in network part. It can communicate with the with each local container, but there is a layer of separation also. You can separate. You can communicate like this container will not communicate with the others also. That's what also we can do in terms of Docker. So it means that segregation of duties we can do. We can assign the task to the container for which he has to do. Now service oriented architecture, it's like okay, so same thing. It's like whatever application we have run for DB application or any other services, it will assign and it will do that, because we have so many now service oriented architecture came into. We can apply that on container and it will perform the same task. Security level we have also, because nowadays Docker is using a high level security, and we can assign that and we can make sure that the other whatever security level we can assign, it will perform the same things. Scalability also we can increase anytime. Let's say your at any point of time, if the if load is high, and we can scale up, that we need a more number of containers to be run on that point of time. So it we can do that. Number of instances we can increase it. Reduction in size also we can do. So it's like nowadays it's like scale up, scale down we can do. Image management is very higher, very good. They have a Docker hub, their private repository. You can store your images there, and anytime if you have uh, let's say development team or UAT team or any, you want to give the authentication to your separate team, to download the image or to use that image, we can do that. So Docker, it's a image management is very high. It's all of IT industry is using that, and it's very cost effective, very it's like flexible. We can use that. Networking concept is it's really here. If you study, they are using uh, host network, and then Ethernet network, and then I think five or six network we have. This topics I'll cover later, but it's very good networking concept. I mean, they are using that where we can assign the networking to each and every container. So and the volume management means it's like storage concept we have. You can bind mount, you can store your data in the cloud or in locally. It's not a good practice uh, to store your the volume locally, because anytime if your container down, the data will be lost. So that's a volume management. What we can do, we can bind that uh, to uh, to NFS or any other machines, and then so that if your container goes down also, your your data will be stored. So it's like you can keep your data out of your container, or it's a NFS or other you can say cloud and all. Okay. So if you see here like Docker architecture, so we have a it's a host, Docker host, okay, and then client. So Docker basically Docker build and Docker pull and Docker run we have. So, and this is in Docker registry where your image will be there. So you can create your own registry also, or otherwise Docker Hub is the by default Docker registry where you can keep your images anytime you can pull or you can push your image. Okay, and Docker host. So in the Docker host, Docker daemon is running. So what exactly it will do? If you see, if you want to understand Docker architecture is, let's say Docker build I have. So Docker build is nothing but you want to create a image for one, let's say for Nginx or anything you want to create. So what exactly it will do? It will check whether in the local host cache whether that image exists or not. If not, then it will download from the registry, and for you it will keep your Docker images here. So Docker, there are three mainly things we are using for Docker architecture: is Docker build, Docker pull, Docker run. Docker pull, what exactly it will do? It will check whether the image it will download the image for you from the register, and locally it will keep on your machine. So Docker pull is nothing but the fetching of the image for Nginx or any images what you want, you can keep there. Docker run is if you have an image and if you want to create a container with that image, so Docker run we can use it. So it's like Docker run will go and then it will check with the Docker daemon. If it will find their image on this local host with this image, it will create a container for you. So this is the Docker architecture where we used the Docker client, Docker host, and Docker registry. And Docker registry is nothing but, as I said, it's a local registry also we can create, and we can keep our Docker image locally so that whenever needed, we can customize that, and we can keep in our local machine, or else we can with that customized image we can modify that and we can push to the Docker Hub also. And here we have like whatever image you have, we can create a Docker run is the main command for creating a container with your Docker image. So let's say Docker image you have, Nginx or any other image, run that, it will create a container for you. So it's Docker build, Docker pull, and Docker run. Now, let's say Docker nowadays, Docker basically Linux machine we can use that. So by default, it will come here where Docker client, Docker daemon is running, and with Docker daemon, your container will create. So basically, it is based on the Linux only. But if you want to use your Windows machine, so what happens in the screen? You can say so Docker client will communicate to Docker daemon, okay, and then you can install it because this is on Linux VM. You need to install a VM, Linux VM on that on Windows machine, and in the VM your Docker host will be there, and uh, Docker host will have a Docker daemon. This is Docker host. This has Docker daemon. Okay, so Docker host will have Docker daemon, and then you can run your container. And here we are communicating with the Docker client, and here it's a Docker client with for window. It can communicate with the Docker daemon. So it's we have a steps also in the next session. We can see how to install this, but it's a good practice. We can install in anywhere in AWS. If you have access, you can install it. Otherwise, for architecture, your own architecture, let's say, or you can install your Docker host. It's a very good document we have in the Google, and we can refer that for installing our Docker in any of the architecture in Linux architecture. Okay. Now, see, if you're asking like what exactly, as I earlier I updated you, like what exactly this our container structure will be there. What exactly it will have here. So each and every image, okay, each and every image will have a host server operating systems, and this is I told you like it's a if you want to understand the Docker image, it's a binary library file for that to run your application, and top of that your application will run. So this is what I'm telling you. This is like This is container runtime means yeah, it's a Docker uh, it's a Docker daemon, and it will be having like this is the container runtimes, and on top of that your binary library will be there. So each and application you can see that separately application will have their separate binary and library file. So if it is one encapsulated, so this is one container for you. So uh, it's like you if you want to if you want to customize your image, you can do that. If you want to modify your things, like you need to write Docker file for that, and you can build your own image with your Docker file. So same it's a one, it's a same for other two, and same for application A. So you can run number of containers on one some single host server by running this one, with the container structure. Yeah. Thank you for watching this. Yeah. Thank you. Thanks all.